Hello friends, welcome to another tutorial in machine learning. In this interesting tutorial, we'll talk about text classification problem of Yelp reviews, and we'll also talk about the anomalies in text classification models due to double negations in human communication and expression, sarcasm, and indecisiveness in speech due to lack of conviction. So there are some reviews which are not positive, or they are not negative. They're moderate in nature. So how does a machine respond to those reviews? How correct is the response of the machine to that reviews after it is trained? So I've selected a data set from TensorFlow, and it's Yelp polarity review. It's a large data set of 5,60,000 reviews, and that is why I've selected this data set, and it has a binary classification for all the reviews. It is either positive or it is negative. So if a review is positive, it gets a 1. If a review is negative, it gets a 0. For example, if you look at this review, the food is super good, ambience is excellent, exceeds expectations, serving time is great. So this looks like a completely satisfied customer, so it gets a positive, so it's a no-brainer. So it's 1 is assigned to the target variable for this review. And if you look at this review, it's kind of dicey. The food is just about tasty, the rooms are tidy yet very small. So he has some complaints and some things good to say. Then we have this review: the food is disgusting, and the service is above average, and ambience is noisy. So he's also a mixed bag kind of a thing. But just look at these reviews. I've got to write this review after a compelling stay at the hotel. So these reviews are a little complicated in terms of machine to comprehend. So we'll look into the performance of the machine if we input these kind of reviews to the machine. Now look at this review. The food is kind of okay, but the ambience is not that bad. So it's a double negation in the speech. Rather, it exceeds expectations. The food serving time is below optimal. Although below optimal is a good thing for food serving time, but the machine might just think that it is below optimal, so it might just predict it wrong. So let's see how does our machine react to that. So for that, let's go to the Jupyter notebook. And by the way, I'm not going to explain this program. You could download this program from my GitHub, and we'll look into the results, and we'll see that these anomalies are the reason why the advancements in text classification as sarcasm detection, sentiment analysis is happening all around. So we import TensorFlow as TF, we import data sets from TensorFlow, then we import TensorFlow Hub. Now why do we do that? We have this pre-trained model from Google with the 130 GB corpus of data, so it's pretty handy for training because this is being trained over millions and millions of words. So we copy this model and we directly implement that model in our input layer. So that is why we've imported this TensorFlow Hub. You could see the list of all the TensorFlow data sets using this command tfds.listbuilders. And then this step takes time when you split the data that you import. So tfds.load, you are importing Yelp polarity reviews, and you split the data into train and test, and you assign it to new data sets, train data and test data. So this might take some time. And then if you want to look at a batch of the train data, the first 10 reviews. You could see it using the iter and next commands, or these functions are needed to be called in nested operation iter and next to see a batch of 10 reviews. And if you see TEB now, so this is the first 10 reviews. Mediocre burgers, I wish I would have read Megan P's review before I decided to cancel my dinner. So all kinds of reviews. And if you see the targets for these TEBs, I've assigned this batch of 10 for the example batch and their label batch. Training example batch, training label batch. For each example we have a label. For the first review, the first example review, it is a positive review, so we get a 1 here. The second is a 0, so quite a few of them are negative reviews. The last one is a positive or review. So you can see the targets of all these reviews using this command. And then this is the important step that I was talking about. I assign a variable pre-trained model, and I've supplied the website's URL from where it'll get its training from the Google News data swivel. And my hub layer is hub.keras layer. Pre-trained model input shape is kept blank here, and data type is tf.string, which you can see it from here. So this is the input type, and TensorFlow string, and it is trainable is true. So my input layer, which is going to be the hub layer, it is going to be trained by this model which is already available on the internet. And then if I see my hub layer after training, we see that these reviews, these English reviews, have been turned into an array of numbers. So you need to kind of trust that model that it has converted your review, which is in simple plain English, into numerical values in a good way. And this is, by the way, the first review. This is the second review. And then let's define our model. It's a sequential model, so we add the hub layer, which we have defined here, and then we add another dense layer, and the activation is ReLU. Then we add the output layer, for which we have just one target variable, one neuron, and the activation is sigmoid. So the reason I've kept sigmoid is that I do not wish it to be a concrete 1 and 0. Depending upon the review, I wish to assign a probability between 0 and 1, where 0 is going to be a purely a bad review, 1 is going to be a purely positive review, and anything in between will tell us the degree of positivity or negativity. So we see the model.summary, then we compile the model using optimizer Adam, loss binary cross entropy, and metric is accuracy. Then this step is model.fit. We train the data, we shuffle the data, we specify a batch size of 512. Epochs is 20. You could increase the number of epochs. I've used 20 epochs, and I've gotten an accuracy of 0.9364. so you might wanna increase the number of epochs to increase this accuracy further. And let's see, the first review that we wish to check is the food is kind of okay, but the ambience is not that bad. So this was more of a positive review, because he's not complaining much about the food, and ambience is also not that bad. It rather exceeded expectations, and the serving time was below optimal. So you can see this was more or less of a positive review. However, our trained model assigned just nearly 0% probability to this, so it has shown it as a negative review, 0.04. So it has misinterpreted. The model has failed to perform on this. So I've labeled this. Let's check the accuracy of the model with a tricky review. Though the model works well with easy comprehensible keywords, so this is super good, excellent, so you get a 95%, which is closer to 1, so it's a positive review. And this one is predicted beautifully. The food is just about tasty, the rooms are tidy yet very small. So this is kind of something in the middle, so we get a 64% probability, which is more inclined towards positive and lesser of a negative review. Then we have food is disgusting. So just looking at the word disgusting, it has placed it into a negative territory. And then this one, I've got to write this review after a compelling stay at the hotel. It was compelling in more than one ways. The hotel serves literally the food you will not find elsewhere. It is sort of ecstatic. To hang out at the pool, which was surprisingly huge with low fees. Rooms are tidy, cozy, and up to the mark. This should have been a positive review, and our system has given it a negative thumbs down. So that is how a lousy trained model could show a lot of anomalies in text classification. So that is why we need more techniques to fine-tune the models for text classification. That is why the need of sarcasm detection, that is why the need of sentiment analysis pops up. And I hope you enjoyed this video and you got something out of it. If you need to download this notebook, you can go to my GitHub page and download it for free there. And if you liked the video, give it a thumbs up. I'll see you around in the next video. Take care. Bye bye.